And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. What we're looking at here is a three-way composite of the last 24 hours of solar activity in three different spectra here. So we're looking at the magnetogram as well as 304 and 171 angstroms. On today's Daily Space Weather video, we'll be talking about volcanic prediction, electron puddles, and climate ignorance. Yes, we will feature a sharticle today on the Smash News Network. Here's another composite image. This is the magnetogram along with 171 angstroms alone. Sunspot 2814 down here in the Earth-facing zone, just moving out of the sort of the solar prime meridian, I guess you could call it. Also, I would note an area of activity rising over here in the southeast, perhaps another sunspot about to happen. We've also got coronal mass ejections to show you. Here's 193 angstroms, and we can expect to see a coronal hole wind stream from this in a couple of days. We'll get to that momentarily. Great close-up here of the South Pole coronal hole system as well as sunspot 2814. Here's 94 angstroms for the same region. And we'll also show you 171 angstroms from this same view. Some minor flaring did happen here over the past 24. Some B-class flares happened. We'll get to it. And here's the magnetogram by itself. And you can see sunspot 2814, according to the magnetogram here, was quite stable over the past 24 hours. Not a lot of migration of the fields. Not a lot of changing of the fields, period. Hence the term stable. Here are the coronal mass ejections we're talking about. They occurred on the far side of the sun. The Earth would be off to the right of your screen in this direction. Great view of this significant far side coronal mass ejection going on here. And we'll also show you the LASCO C3 to see a rather deceptive thing happening here. First of all, we've got Venus and Mercury. And you can see this coronal mass ejection looks like it may be Earth-facing, but it indeed is the opposite side of the sun. And that's why you get this halo appearance. It looks very similar to a coronal mass ejection approaching the Earth in an Earth-facing sort of direction. This one, I assure you, is indeed not Earth-facing. It's on the opposite side of the closest star. Here's a diagram of the solar system. And there's where things will be in a week. Here's a star chart. We show it daily. I like to face mine to the south. I use in-the-sky.org. If you want to make your own, head to in-the-sky.org. Put in your location. If you're up before dawn, you may see Saturn and Jupiter rising ahead of the sun. This yellow line is the ecliptic. The 10.7 centimeter radial flux dropped all the way back down to 73, an indication that perhaps sunspot 2814 will degrade today. And here's the radial flux in context. This black line up here, up top, that is the 10.7 centimeter radial flux over the past year. The red line down here is the sunspot number. And here you can see in 2 days, late on the 16th, we're expecting the arrival of the coronal hole wind stream, at least NOAA is. And you can see they're forecasting some geomagnetic unrest. I wouldn't be surprised to see it briefly reach into geomagnetic storm conditions, as that coronal hole is extremely well defined. So in about 2.5 days here, we're expecting to see a geomagnetic unrest, at least according to the NOAA forecast. Were you aware that we can detect the ground heating up before volcanoes erupt? Now, volcanoes are relatively easy to forecast when it's compared to the forecastability of things like earthquakes. Earthquakes very hard to forecast. In fact, they're not really forecasted, period. But it turns out we can forecast volcanic eruptions here basically with infrared satellites. So the upwelling of magma and other gases cause the ground to heat up, and that geothermal heat is detectable from satellites, and that gives us some warning, as well as other seismic information about when indeed a volcano will erupt. And this article is from yesterday, April 13th, on phys.org in phys.org's Earth section. And we're just letting this scroll here before we move on to see what's erupting today. And on the list is Sakurajima, which exploded and produced a 5,000-foot plume of ash. Suwanosejima, 6,000-foot plume of ash. Cinnabung, 10,000-foot plume of ash. Dacono, exploding as well. 7,000-foot ash plume there. Popocatépetl in Mexico, exploding. 21,000-foot ash plume there. Pacaya in Guatemala, exploding. 10,000-foot ash plume there. Revenador exploding. 19,000-foot ash plume there. I'm sorry, Sangay. Sangay, 19,000-foot ash plume as it explodes in Ecuador. Revenador, volcanic ash not observed in satellite. Sabancaya, continuous ash emissions. And Soufrière, the partially evacuated island of Saint-Vincent, has been exploding and producing an 11,000-foot plume of volcanic ash. And I guess now is as good a time of any to remind all of our viewers on YouTube to not pole vault the caldera. This public service message brought to you by smAshomash.com. Largest earthquake of the past 24 was near a tri-plate boundary west of the Galapagos Islands. This is actually the Galapagos Island chain here, folks. This is where the 5.7 magnitude quake, the largest quake of the past 24, occurred. West of Ecuador and Colombia, out in the Pacific Ocean. And let's check the list here, going back the full 24 hours. A couple 5 magnitude quakes. We did see a deep quake at Fiji, a 4.6 magnitude at 535 kilometers depth. Also at Bolivia, there was a 4.0 at over 230 kilometers depth. And Chile saw a 4.3 at 137 kilometers depth. Largest of the past 24 occurred at 4:33 this morning on April 14th. Again, a 5.7 near the Triple Junction region there. And here's the rest of the list scrolling. Nothing else of note. So we saw some minor flares here. Let's see. It looks like 3 B-class flares have happened today, as well as some B-class flares yesterday. That's the GOES X-ray flux. Solar flares. And don't get solar flares confused with coronal mass ejections. Solar flares are photons. Coronal mass ejections are primarily protons. And we don't see any strikes on the GOES 16. There's the 3-day chart of the proton flux and the GOES magnetometers over the past 3 days as well. There's the data from that. And keep in mind, we expect to see some sawtooth patterns in the GOES magnetometers in the coming 2 days, as we've got a coronal mass, a coronal hole wind stream about to arrive late in the day on the 16th, which will cause some spiky sawtooth patterns to occur in the GOES magnetometers. And for you new viewers, the N's and M's stand for midnight and noon local time for the GOES 16. Let's take a look at the current sheet, the heliospheric current sheet. This is the top view ecliptic plane field plot, which is part of the daily Gong 2 data that we show. It's part of the National Sunspot Observatory. And you can see Earth is solidly in the South Pole current sheet. In fact, the South Pole current sheet is currently dominating the ecliptic plane on which the Earth rotates, revolves, etc. And let's take a look at it from a different view, the line of sight coronal hole plot. And you can see this large, very well-defined coronal hole. There's actually a coronal hole leading sunspot 2814 as well, as you can see there. And here's another view, line of sight ecliptic plane field plot. Basically a three-dimensional representation here of the shape of the current sheet. And you can see how South Pole oriented the earthly portion of that current sheet is. South Pole magnetism shown here in red. Here are the filaments and sunspot groups. Likelihood of an Earth-facing coronal mass ejection is pretty low right now. Possibility of some solar flares is somewhat elevated here with a beta-class sunspot 2814, although again it's been pretty stable here over the past 24. We'll be keeping an eye on it, and when I say eye on, well, the pun is intentional. Here's the KP index, a measurement of global geomagnetism. Current conditions are a KP of 1, calm geomagnetic conditions. Next, we'll look at the real-time solar wind, something that we show daily here at the Smash News Network. Least busted. Name of news. Pretty uneventful here over the past 24 hours. Current solar wind density 5.57 protons per cubic centimeter. Current solar wind speed just under 400 kilometers per second. Pretty much background levels there. Here's a geospace magnetosphere movie. It's 4 hours of data, courtesy University of Michigan. And we're seeing pretty uniform pressure here over the past 4 hours. Nothing to write home about. We show it daily to help to create somewhat of a record of what went on. Here are ground magnetic perturbations. Geospace delta B, in other words, changes in the Earth's B field, also measured in nanotesla. And you can see some perturbations here on the Antarctic continent, south of the geomagnetic pole, which is someplace around here. As well as some in the north as well. Pretty minor. Again, 4 hours of data there. Let's talk about sulfur dioxide. Look at all the sulfur dioxide crossing the central Atlantic Ocean here, heading from South America over to Africa. It's an exchange of sulfur for Saharan dust, perhaps. And if you haven't seen it, you probably haven't been to our Discord page. We do have a Discord channel, folks. If you haven't checked it out, check it out. And you can find links to it. You need an invite to join a Discord channel, folks. You need an invite. And if you head to smAshomash.com, you'll find that permanent link invite. Allow me to show you at smAshomash.com. And welcome to the Neo Renaissance at smAshomash.com. Underneath this arrow here, you'll find all of our social media, and there is the permanent link to our Discord channel. Feel free to join up, as we'll be using that in the future. Thanks to our Twitch viewers, by the way. And while we're not streaming live currently to Twitch, it is a thing. Twitch.tv/SmashoMash if you'd like to know when we go live. We don't only do YouTube live streams or uploads to places like BitChute. We also do Twitch live streams. And don't forget to press like and subscribe if you're viewing the content on YouTube. Yes, YouTube. Where fraud is promoted and where no matter how consistent your subscriber count is, you don't say anything else about it. Thanks to our BitChute subscribers also. And we've decided to go live here at the Smash News Network, Least Busted Name in News, for our cosmology segment. Let's get to it. Today's cosmology segment features an article here about ghost particles, otherwise known as neutrinos, the least massive particle known in the universe. And this is an interesting one as it's talking about a tidal event. So the massive radio sources located at the cores of galaxy, commonly referred to as supermassive black holes, we'll just refer to them as massive radio sources, they spit out jets of material. When those jets are oriented directly toward your location, they're known as quasars or blazars. And this particular one is interesting in that it seems to have generated a neutrino as a result of possible star being consumed by the black hole. So these tidal disruption events are believed to involve a star getting too close to the event horizon, part of it being drawn in and part of it being blasted out, which powers up the toroidal field and perhaps later powers up the poloidal field. And what we're talking about with poloidal and toroidal fields are this area right here, which rotates around the massive radio source, that is a poloidal field. And these jets emanate from a poloidal field. So know the difference between a toroid and a poloid, folks. That's my best advice. And perhaps check out this article. Another great artist rendition here of what happens during one of these tidal events. Again, this article is on SciTech Daily. The event known as AT 2019 DSG is the alleged tidal event that we're talking about here. So perhaps have a read. A tidal disruption event coincident with a high-energy neutrino is the paper cited in the article. Again, you can find it on SciTech Daily. I think it's a lead article today, actually. And let's talk about triple quasars. Thanks to our viewer who commented on this. We were talking about double quasars a few days ago. Now we're talking about triple quasars. Here's a phys.org article about it. Extremely rare, a triple quasar. What's so rare about it? Well, what's so rare about it is that this particular galaxy has 3 extremely massive radio sources at its core, and each poloidal field is oriented toward you, which means all 3 of these galactic cores are oriented in the same direction. So you've got 3 of them, all of which have their poloidal fields oriented toward you. So this is believed to be a result of a galactic merger. You can see A, C, and B. Those are all quasars located in galaxy J1519 plus 0627, the triple quasar system. Now this article is all the way from back in 2013, but you can find it just for searching triple quasar. This one is in the phys.org section. A very rare scenario, QQQJ1519 plus 0627 is the galaxy in question. Let's pick a random object real quick. Today's random number is 340. Let's see what it coincides with at the Neil Gorell Swift Bat X-ray Observatory. It's V906 Carinae, some sort of an X-ray source, and you can see it's a very diffuse X-ray source. And it's only recently been monitored here. The historic graph only goes back to earlier this year, so this one's super interesting in that it's quite new on the list. But it's also a very weak X-ray source. As you can see, the levels here are only 0.005, for example. And let's see if we can get a visual of this, and we cannot get a visual of this as there is no link to Sinbad here. So let's move on. There's even more cosmology stuff to cover. Is this even cosmology? Well, what about 3D superconductors, which form into 2D superconductors, which cause pools of electrons to spontaneously form? Why? Because of the intrinsic properties of the superconducting materials. Now, does this apply to space? Some of us think it indeed does. But anyway, it's another SciTech Daily article. It's as if when given the power to superconduct, the 3D electrons choose for themselves to live in a 2D world. Does this have something to do with what's going on with stars? Well, one of the problems, folks, with mainstream heliophysics as well as other alternate theories of how stars behave is, where do all those electrons come from? And guess what? If they come from the intrinsic properties of what the stars are made of, condensed matter, then perhaps that is where the electrons come from. It's pretty important as the solution to where all those electrons come from. How the stars behave the way they do is kind of important, and maybe somebody's figured out in a lab how that works. This is a repeated thing here, by the way, as Stanford replicated the results. Puddles of electrons forming into their own 2D structures, as if by their own will. And that's today's cosmology segment, a regular feature here at the Smash News Network, least busted name in news. And we'll have to say goodbye to Twitch until we return for our meteorology segment. In the meantime, let's get back to the daily space weather data. Here's the electron flux over the last year, and we can see very low levels here. Here's a 3-day chart. Again, that's a 1-year chart. There's a 3-day chart. And I would concur with this model here, this forecast model. The green boxes are the forecast, the yellow diamonds are the observation. And I would say that I would tend to agree with this, as again, there is a coronal hole wind stream on the way. Here's a diagram of the Van Allen belts. If you need to pause the video, feel free. Here's a visualization of the total electron content forecast. And we expect to see rather chaotic bands of electrons here. Don't be surprised to see GPS errors at night, especially if you're around the equator. And indeed, you can see those blobs forming there, creating things like GPS errors, as this is a visualization of the entire air column, all the way from ground level up to where your GPS satellite is located. And when it has to communicate through giant electron shells, it's got to, there's going to be errors. Let's just put it that way. And not surprisingly, we see less organized Van Allen belts as a result of low electron flux. It's just a feature. Here's another diagram of the atmosphere, folks. And we're showing this to show that red F. That red F right there, that's the F ionosphere layer, located at about 300 kilometers altitude. And here's a visualization of that. This is showing you 15-minute ticks. Each tick of the clock here, every second is showing you 15 minutes. And we see some pretty anomalous ionospheric behavior here, consistent with these low levels of electron flux. You can see some pretty oddly shaped ionospheric vibrational blobs happening. And these blobs are vibrational frequencies, folks, in megahertz, millions of vibrations per second. And let's bring up the latest image here. Very discharged ionosphere here in the past couple of hours. There's the latest image from 9:30 Universal Time. Pretty anomalous in the ionosphere. Let's talk about a sharticle. Before we talk about the sharticle, let's welcome back Twitch. Hey Twitch, welcome back to the Smash News Network, least busted name in news. We don't print sharticles, we expose sharticles. If you're not familiar with the term, sharticle, noun, often vulgar. 1. Particulate matter expelled from the anus due to a shart. 2. Shitty article, often propaganda. Usage. Look at these sharticles in my drawers. Or, better yet, Phys.org's Earth section is rife with sharticles. Here's one. Snow chaos in Europe caused by melting sea ice in Arctic. Oh my God, we're all going to die. Sea levels are going to rise, and weather is going to get more extreme, even though weather hasn't gotten more extreme, because of sea ice melting, folks. And who knows? Who knows how long it'll be until we don't see any snow anymore. Oh my God, the planet is so hot that it's cold. And yeah, I read this article. I refrained from losing an IQ point by doing so. Notice how they're talking about long-term trends from 1979, which is the coldest period in modern history. Oh, it's the beast from the east from 2018. Oh my God. Let's talk about some actual data. Now, I've noticed certain YouTube channels seem to not know what the hell they're talking about when it comes to Earth's rotation speed. The explanations for the speed of the Earth's rotation increasing are just ridiculous and nonsensical crap that I've been hearing all over YouTube. Why is Earth speeding up? Well, there's a couple logical explanations for why Earth would be speeding up. The main one would be less water in the ocean. In other words, if you have more snow and ice deposited toward the Earth's poles, you would have a faster spinning Earth. Also, if the ocean got colder, the Earth would spin faster because warmer water has greater volume than colder water. So, a logical explanation of why the Earth's rotation has been speeding up would be global cooling, the same way a ballerina speeds up if she's spinning around and she pulls her arms in, or also a figure skater, right? When a figure skater's spinning around and she's got her arms extended, when she brings in her arms, she speeds up. So does the Earth. And this is a known thing, that lower sea levels are associated with a shorter day. Why other YouTube channels aren't telling you this, I have no idea. I just think it's because they have their head. I think they're viewing the world through their ass because their head is deep in it. Deep in their ass. And they have no idea what they're talking about. They make millions of dollars per year by just shoveling a bunch of nonsense onto your screen. Here's some non-nonsense. The sea ice thickness in the Arctic as of April 13th. So here's the historic chart here, and you can see that we did see pretty low levels last year of sea ice volume in terms of, this is the thickness, folks. So satellites need to measure the thickness of the ice to really have an understanding of how much ice is there. And that's how the volume is calculated. In other words, the extent times the thickness. And we're really in the range here. I mean, you've got a 10-year range represented by this shaded area. And you can find this data yourself at the Polar Portal, which is the Danish Meteorological Institute. You can also animate this and look at different versions of it and look at historic data. But more importantly, I would look at all the snow. So you can see the snow mass balance made it 2 standard deviations above the normal range. The blue shaded region here is the 30-year range, 1982 through 2012. And you can see the way that the snow mass, and this is not counting mountains, by the way, which also receive a lot of snow, Is water being deposited from the ocean at the poles? Is that what's causing the Earth to speed up? Anyway, here's the snow cover extent, which you can see made it outside of the 1 standard deviation range earlier this year, back in February. So that's just the extent, in other words, the square mileage covered by snow. And here is the snow water equivalent. And you can see this is well outside the 1 standard deviation, an indication that a lot of water is not at the equator. The Earth has an equatorial bulge, folks. And the Earth's equatorial bulge slows down the Earth's rotation. In other words, if sea levels rise, the days get longer. If sea levels drop, the days get shorter. Water is very massive, and again, the equatorial bulge shrinks when water gets deposited as snow and ice at the poles, which causes the Earth's day to speed up. I hope that helps. I hope that helps to dispel nonsense. And let's talk meteorology. Here are the surface winds of the Western world. Powerful winds here south of Alaska, as well as at the tip of South America. You can see some very strong winds down there as well. Wow. Hurricane force winds there south of South America. In the, I believe it's the Drake Passage, right? One of the most dangerous portions of ocean on the planet. Here are surface winds of the eastern world. And we'll show you the jet streams also. And let me just make sure the live stream is doing okay, and it looks just fine. So there are the jet streams of the eastern world. And by the way, extreme meridional jet stream flow, when the jet stream is flowing north and south instead of west to east in the normal fashion, is what causes extreme weather, not carbon dioxide. The idea that it is carbon dioxide causing extreme weather is absolutely idiotic. Similarly idiotic to the concept that carbon dioxide drives the climate. Here are pressure cells, according to windy.com, and we're going to advance this into tomorrow. Here's the GFS forecast for pressure at tomorrow, noon Eastern Daylight Time. And if you're wondering where we're located, Smash staff and I are located right about there in Lehigh Valley, Pennsylvania. We've got more meteorology. Here's lightningmaps.org, and we see some lightning happening. Shreveport. There's thunder rolling in Shreveport. Yowzers. So some pretty heavy storms here, just moving out of Texas now into Arkansas, Louisiana, soon to be in Mississippi, Tennessee, Missouri, Kentucky, etc. Here's a U.S. Doppler radar map. Snow continues to fall in the southern Rockies, as well as Utah, Nevada, Montana, Minnesota, and Wisconsin. And our next graphics should help give you an idea of how these heavy storms are going to be moving. Here's what's going on in the cloud layer. A bunch of low clouds over the Atlantic once again, as well as the Gulf of Mexico. Here's the water vapor map, and back to the cloud layer, and back to the water vapor map. Rapid cloud nucleation happening here near the Texas-Louisiana border, as well as in Oklahoma and Arkansas and East Texas. And this low pressure system is stagnating here around Lake Superior. You can see that counterclockwise rotation surrounded by a band of dry mass of air. And most of the moisture in the central part of the state of the country is going to continue moving in the northeasterly direction. Again, there's the cloud layer, and there's the water vapor. And that's today's meteorology segment. And we'll have to say goodbye to Twitch once again. Goodbye, Twitch. And now we've got some bonus features. And thanks for leaving a comment, Be Stoic, who says, what about the other planets experience climate change observed? I don't know. All right, so let's take a look at some National Sunspot Observatory data here. We'll look at El Teide, Spain. Here's El Teide, Spain's ground-based solar observatory data. And it looks like they've got some clouds there, as we've got some anomalous-looking data there. Sunspot 2814 is visible. Thanks to the Smash team for tuning into the video. Thanks most of all to our patrons, the true source of funding for this content. As without our patrons, these videos may not exist. Please consider becoming a patron to help fund us going forward. Patreon.com/smAshomash. And here come the rest of our bonus features. We're going to show you the high-resolution solar magnetogram. And there's that. And here's the intensitygram. Sunspot 2814 remains beta class. And let's press refresh here to get you the latest that we can muster. And is there another sunspot forming down there? Well, I'm not so sure. But there's 2814. And it looks like it's remained pretty similar. It looks like it's actually degraded a little bit. So I think it's actually degraded a little bit in the past half hour, folks. Here's another full disk image of the closest star. Thanks for tuning in, stargazers. Check out how defined that coronal hole is. This one down here. It's so defined it's showing up very well in ionized helium, 304 angstroms emission spectra. And last but not least, here's 171 angstroms. Again, eyes on this area over here, as it could be another active sunspot rising. Thanks again for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink it. If you do, don't drive. Once again, welcome to the Neo Renaissance, and may that solar wind be at your back.